Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today, for exam P, on probability. Let T1 be the time between a car accident and reporting a claim to the insurance company. Let T2 be the time between the report of the claim and payment of the claim. The joint density function of T1 and T2, f of T1, T2, is constant over the region where 0 is less than T1 less than 6, 0 is less than T2 less than 6, and T1 plus T2 is less than 10, and 0 otherwise. Determine the expected value of T1 plus T2, the expected time between the car accident and payment of the claim. So we write f sub T1, T2 of T1, T2 for the joint density function of T1 and T2. The region where this joint density is positive is shown in the graph that I'll show you in just a moment. The area of this region is the difference between the area of a 6 by 6 square and a small triangle cutout, which is actually half of 2 by 2 square, so that the area equals 34. And since the joint distribution is uniform, the density is equal to 1 over 34. And the region where that happens is where T1 is between 0 and 6, T2 is between 0 and 6, and T1 plus T2 is less than 10. And let's take a look at the picture of that. So here is the picture. And the point I was making about the cutout is, if you take a look at this line where T1 plus T2 is equal to 10, which is the same as T2 equals minus T1 plus 10. So it's a straight line with a slope of -1, with the T2 intercept of 10 and T1 intercept of 10. Because whenever one of the T1, T2 variables is 0, the other one is 10. And it cuts this 6 by 6 square at the points where T1 is 4 and T2 is 6, and the other point is where T1 is 6 and T2 is 4. So this way you can see that it cuts out half of the 2 by 2 square in that upper right corner, and area of a 2 by 2 square is 4, and half of that is 2, so that the area of the region where T1 is between 0 and 6, T2 is between 0 and 6, and the points T1, T2 are under the line where T1 plus T2 is 10, because we want T1 plus T2 less than 10. So the area is 6 times 6, which is 36, minus that cut out little triangle, which has the area of 2. So the area of the shaded region is 34. That's why the density is 1 over 34. And now consider the random variable s equal to T1 plus T2. It takes on values between 0 and 10. For a fixed value of s equal to some specific little s, T1 plus T2 is s, so that T2 is equal to s minus T1, so that the corresponding values of T1 and T2 lie on a straight line with equation T2 equals s minus T1 of slope -1 connecting the points 0, s and s0 when s is between 0 and 6, or the points s minus 6 and 6 and 6 and s minus 6 when s is between 6 and 10. So there are two thick lines indicated indicating these two cases in the figure, and let me show you that. Here it is. The first line is over here. Okay, and you see that it has a slope of -1, and the sum of the two values, T1 and T2, is s along this line. and s is less than 6, and the intercept, the t2 intercept is where t1 is 0 and t2 is s, and then a t1 intercept is where t2 is 0 and t1 is s. But for the second case, where the sum of the two is more than 6, so the sum will be actually the intercept here, or intercept here, but we have to be within this shaded area. That's why we only look at the line within that region. So in the second case, the boundaries are where t1 is 6, and because the sum of the two is s, t2 has to be s minus 6. And here in the second endpoint, t2 is 6, so t1 has to be s minus 6, so that the sum of the two is s. Okay, so what I said, you can see is by beginning with the line t2 equals 10 minus t1, and letting that line move in parallel shift fashion towards the point 0, 0, in that process moving through two cases illustrated by thick lines. And in that extreme case where you reach the sum of the two equal to 10, that's the boundary line going down with a slope of -1, which cuts out the triangle. Okay, so based on this reasoning, we calculate the survival function of s, the sum of the two. The probability that s is more than a specific value of s is the probability of being above that thick line indicated. And there are two cases where s is between 0 and 6, and what are the chances being above that line, and then s is between 6 and 10, and what are the chances of being above the thick line. So in the first case, it's 1 minus the area of triangle under first thick line in the figure, divided by 34, because 34 is the area of the whole region. And in the second case is the area above second thick line, and the second word above relates to the picture, which I will show you again in just a moment, divided by 34. So okay, we're looking for the probability of being above this line or above this line. And in the first case, we just make it 1 minus the probability of being under the line in this triangle in the left or lower corner. And in the second case, probability of being above the line, we have to figure it out, but you can kind of see that if it wasn't for this cutout triangle, it would be kind of easy, because it would be the area of a triangle, but it is the area of the big triangle minus the small cutout triangle. So for the first case, when s is between 0 and 6, this is 1 minus 1/2 s squared, the area of a triangle with a right triangle with two sides, perpendicular sides of length s, divided by 34. In the second case, it's 1/2 of 6 minus s minus 6, the whole thing squared, begin to, that's this bigger triangle, half of the product of two perpendicular sides length, minus 2, minus the small cutout triangle. And the first thing ends up being minus 1 over 68 s squared plus 1 for s between 0 and 6. And the second thing ends up being 1 over 68 s squared minus 6 over 17 s plus 35 over 17 for s between 6 and 10. And you know why I'm calculating the survival function. We're looking for the expected value of this random variable. The random variable is non-negative with probability 1, so we're going to use the Darth Vader rule. So the expected value has to be equal to the integral from 0 to 6 of minus s squared over 68 plus 1, plus the integral from 6 to 10 of s squared over 68 minus 6s over 17 plus 35 over 17. And the first integral is minus s cubed over 204 plus s evaluated from 0 to 6. The second one is s cubed over 204 minus 3s squared over 17 plus 35s over 17 evaluated from 6 to 10. And we write out all the fractions that we get that way for all the values. And that ends up being equal to 292 over 51, or approximately 5.7255, which is answer C. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.